with that, we will head over to our next presenter and our next presentation. Welcome, Felix, to Func Prog Sweden. Hello and welcome, Felix.
Thank you, thank you.
Warm welcome. The stage is yours, and you're going to go on with Electric Clojure plus Rama. Very interesting.
Thank you. Thank you. Long-time lurker, first-time presenter.
Yes. Very exciting.
It's just to loop in on Eric's talk. I think it's amazing that you're actually doing extreme programming at such scale, and the thing about doing a production, like you sneak into the production system and do some changes. That's a Clojure thing as well. I remember doing that just a couple of weeks into my time at Multiply, which I'll talk more of. But thanks for the presentation.
Yeah, you're welcome. The stage is yours.
Grazie. So Electric Clojure plus Rama, a Clojure stack from the future. My aim with this talk is to, like when you leave for dinner or whatever tonight, my hope is that you will know a bit more about Electric Clojure and Rama on a pretty high level. I'm not going to go that deep into the nitty-gritty details because I don't think we have time. Both of them are pretty out there in what, at least to me they are, in what the current state of web development and backend development is today. And they allow things that I wasn't that used to when I joined Multiply. And this talk will be much more of an experience report because I reflected on how the use of Electric. I'll just show you. I'm getting ahead of myself. So this is what the talk will be, and I'll start with the Electric part of the code because it will be in Electric where we are building all of our UI, and Electric also has a little finger in the backend, which I'll get to. Then we'll move on to Rama, which is basically backend plus DB, and if we have time, I'll also touch on some in-house glue that we have on the JVM that kind of glues it all together nicely. It was a baby project of Henrik at Multiply, so it was all in place when I got there, and I find it pretty amazing. Cool. So I've been doing development, both front end and back end, for about 8 years, and the general setup is usually you have some front end code, you have an API, and you have a server doing some things on the back end, kind of hidden from the user. And the API could be either REST, it could be GraphQL. It doesn't really matter in this to get this point across, but that's usually what I've seen. And the client makes a request, it gets to the server server gets you a response back to the client, and that's the cycle you kind of live with as a web developer, or a full stack developer rather. But with Electric, it's a bit different, and with some reflection before this talk, like, okay, so I'm going to do an experience report, it's going to look like this. I kind of realized that I haven't thought about an API in about 4 months now, since joining Multiply. And that's kind of a freaky idea, I feel like. And but definitely an interesting one. The YouTube video at the very bottom, I couldn't really get that animated in at the very end, so it will just hang out there at the very bottom. But you can check out if you want to multitask some. You have a link at the very bottom of the slide with the Electric Hyperfill 2 clocks example that I'll talk it through now with some visualizations. But if you want to have a sneaky peek look, you can feel free. So instead of an API here, in the middle of the client and the server, we have some, Electric Clojure code. Looks very much like Clojure. but with these e/defen, e/client, e/server, e/client. And what this does is it analyzes the code and let's see now, the full example that is in the YouTube video and that some of you might have seen in the 2 clocks example, it's just one file. Like you don't have any front-end files, you don't have any back-end files. You basically write out your UI and you shimmy in some back-end code. And that's all you, like the developer experience, that's all you do. And it is pretty bonkers. So you can see here we have some server code. It's something that calculates the system time on the backend. And it runs, obviously, then on the server. And at the same time, we have the rest, which is client code. And it runs on the client. And Electric takes care of all of the syncing between the server and the client with a WebSocket connection, which keeps everything in sync. So we have I was trying to communicate here that we've named this variable S, which is the server value of the system time. But that S value is gonna need to pop itself over to the client. Electric does this, like that. And it gets to the client now as client S, and you can see a little recording down here with the server time being calculated over here on the right on the server, and the client time along with the skew of like the diff, like the network hop diff of between the server and the client, and that's the time it takes for the WebSocket value to travel. At least when I was on a bus or something, so I had a bit of latency. But it's pretty cool because you don't like the notion of not thinking about the API makes me at least go so much faster with developing these things, because I know the UI. This is what I'm looking at, and I have some backend functions that are already there, or I can just create a new one, getting some data from the database or whatever it is we do in our everyday work. But from more intricate example from the multiply codebase, some background. I don't want to take this spot and make a lot of PR for the company, but it's useful for knowing what the platform is for, and the what's the word? Like the definition of the attributes. There's a word that I'm looking for, but the attributes for what we're building. Basically, we need some asynchronicity. We need some this and that. And what multiply is a AI agent orchestrator that is used from creative agencies. So you can imagine that there are AI agents all calling on each other left and right, starting a workflow, leaving that workflow onto another agent and doing something else, all asynchronously. So, for example, this is the landing page. We have a list of recent projects right here, and we're going to have a look at that code. So the main view, do you think this is a good size? No? So we get it up there a little bit more. So you can see here that if you squint, it's basically HTML. If you compare this view right here. So this is the first section, this is the grid project section. And moving along down here to the grid project, we go to that definition. We can see we're still on the client. We move down here, and a small spoiler alert. The server jump is done at the spaces right here, when fetching the recent spaces. Everything else is client-side code. So the interesting part here is inside of recent spaces. We head in here, and we have some arguments, whatever. I'm not going to touch this closure feature, but down here we have the actual server-side code being run, and it fetches the recent spaces. We're pretty quickly inside of this function heading into Rama territory, which we'll get to later. So I'll just hop back here. Another example here is the on-click functionality on the backend. But you click the button on the front end and something happens on the backend. That's something we're all familiar with in our day-to-day job. So getting back to that. It's in the create atom section, still in the same page. We sneak down to this run function, which is being used further down. This part right here is the primary button. That is the thing that runs it. And all it does, if we jump back up, all it does is it does a React-like thing here, which we've implemented as a hook within Electric. We set transacting and we get the transacting value. I think a lot of people are familiar with this pattern. So when we push the button, transacting gets turned to true. This code gets run on the client side still, but this part right here is the thing that actually creates the prompt which we wanted to. So if I didn't communicate this, it's a prompt box here. You write something for an LLM or an agent to do, and then you run it, and you will get rerouted, and this thing will get created basically. So going in here, we have some server code. There's some thing here that will go into Rama territory, so we'll get there eventually. Well, I'll touch on these things when we've talked a little bit about Rama. So, Rama comes next. What a surprise. It has been mentioned by Nathan Mars, that is the founder of Red Planet Labs. That's the company behind Rama. He fiddled with this for 10 years before releasing the private beta that we're using right now. Yeah, there's a lot of cool things like in this platform. It's interesting that he calls it a platform. It's no library, it's no framework. It is something that you have to buy into, and you have to accept that it looks like this. It's very opinionated, but at the same time, it's generic to a point where you're free to form it to whatever shape you want to, if that makes sense. He's also shaped it to people not knowing what it is. It's, if you want to kind of focus in on it a little bit, it's stream processing and DBs. And that's databases in plural. First time I said that word out loud. But as many, it's DBs. It's many of them. Distributed data stores, it handles deployment, monitoring, it is scalable, and also fault tolerant. The scalability and fault tolerance, I don't think I know that I won't have time to get into, nor the deployment, nor the monitoring. But the thing I'll focus on is the developer experience of the stream processing part and the creation of databases, which we'll get into next. It is at the very base, at its very core, it's an event sourcing system. So to get data into the system, you have to do that by events. And Rama has it has its own nomenclature, but I want to just touch on how event sourcing works. So it all starts with an event log. I worked at an amazing telecom company called Telnus years and years ago, which had their hand-rolled event sourcing system. And they had just one event log, a Postgres table that did all of the event handling. And a lot of listeners then, acted on the new events coming in. But usually, I mean, that's my experience, and to my feeling of it is that many people use one event log. And they push in some customer created, some customer name set, like events about customers. And then you have your orders, you have whatever it is, but they're usually in the same event log. Then you have a listener that handles each and every event, and you do some data transforming, you might do some side effects, it might end up in the database, it might be a third-party service that gets contacted. But this is usually the flow that you're looking at in an event source system, not touching on the querying part of everything, but the feeding into the system with events containing data of different kinds. Usually domain events. So if I was a seller of some sort, or I had a store of some kind, I'd want to create customer, I want to create an order. You get the point. So Rama's event sourcing, I want to talk about how it maps onto this, onto the event sourcing that we just talked about. So instead of an event log, Rama has depots, which is the exact same thing conceptually. You push events into them, and you then read those events and you handle them in an ETL. It's called in Rama, but I'll get to it. It's usually grouped by entity or business use case or feature. So it's not one huge event log. You can create how many depots as you want. So for this example, we used customer and order. You'd probably have a customer depot and an order depot, each getting their events sent to them separately. So we won't mix any order events into the customer depot for obvious reasons. There's a separation of concerns aspect of this, because when you handle the events from a certain depot, it's pretty nice to only have that space of the flow in mind. Like there's not going to be any side effects coming in. It's just going to be basically a function of the event data coming in. You do your transformation, you do your thing, and then you store it somewhere in some kind of data store. So moving forward, we have the customer topology and we have the order topology, which is, as I mentioned before, the ETL, like the data transformation part of this, where you handle each event, you do your side effect. And in Rama, it's the data store that you use is abstracted in as a PState, a partitioned state. So the state, we'll get to it. It can look however you want, basically, based on how the feature and constraints of your feature, like the thing you're gonna build. However that looks, you can shape the data that you're storing custom to that use case. And this is basically the three things I want to underscore. So depots, topology, and PState. These are the things that are, to me, very interesting to understand the data flow and storing of the data in Rama. So let's zoom in a little bit on the topology part, where we actually have Rama has a beautiful DSL for some really cool things. Like it's mind-boggling what you can do with this DSL with just a couple of lines of code. But first, I want to talk about an abstraction that comes up in Rama called a fragment. So a fragment, we all know, well, we don't all know fragments yet, but we know functions, which you can kind of see as a call and response kind of thing. If it's a pure function, it can get one or more arguments to it, but let's not talk about that. I just want to visualize this. Something comes in, something happens, and something is pushed out, or not. If you just want to return null or whatever it is, you won't return anything. But pure function, we go by values, we return something. A fragment is an abstraction over this, where a function can be a fragment, but a fragment in its case is same as a function. You get a call site, or you're at a call site calling the fragment, and the fragment then emits nothing, as the function could also do, or it emits once. At this point, it is now a function. Like, this is the implementation of a function using fragments. It's a call and one emit. Or you could emit multiple times to different subscribers. And if you squint at this, you kind of start looking at this data flow model that is talked about when if you would go and read Rama's documentation right now. The part between an event coming in and it being stored in a PState, this is basically what it is. It's a data flow programming paradigm that sits between these two parts of the system. And that's what the DSL of Rama does. I'm not sure what you would call it, if it's an ETL DSL or whatever it is. It's a beautiful thing. So you have the event right here. Then with the DSL of Rama, you push things into a PState. Or not visualized here, you could go for a third-party notification or whatever it is. So, a PState, you could explain it or describe it as a data shape and nothing else. Because some features of your system would maybe be best expressed, and the data of it being stored in a key value store, which is just a map. It's nothing more than this, basically. There are a lot of providers of key value stores, and you could use any of them, but in the very essence, it's just a map. If you would go on to look at the document DB, or a document DB, it's a map of maps. That's what it is. And the shape of it, we can kind of imagine, would be something like this. It's a document ID linking to the contents of that document. And I'm not going to describe all of the different ways of describing an edge database, or a graph database, I mean. But there are ways of doing this within the PState shape, where you link an edge to a node, and you could have, you can describe amazing things with this abstraction. But I didn't get the time to get it into this slide. But we have an example from our code base right here. So this is the PState of our accounts, and as you can see, it's a map. We can see as much, and each key, or rather, each key value is connected to another map. So this is basically a document database right here. The content isn't that important, but this is what we use to describe and store accounts in our full system, and nothing more about it. Like, this is all we did, and we can reason about the accounts just by looking at this and reasoning about what events do we need. Like, do we need a set status event? Do we need to add an email? But it's nothing more. It's just this flow of data from an event through this data flow programming paradigm into a PState that can look however you like. So going back to this dashboard and looking at the list of projects, we're now going to peel back a little more from the recent projects functionality and that UI, how that works. So we was at the project grid. We're gonna drill down to recent spaces. We're gonna go into the recent spaces. It's a function right here, and it's a query. We're now at the server. I believe, yeah, we marked this as a server code here as well, but you can nest it however much you like. And for the sake of being explicit, it's kind of nice, I think, at least, my opinion, to mark them on each level. We get down here. This is a little teaser of the glue code that we have that I might get time for to talk about. But it takes the output of the Rama query on the topology. If you remember, the topology was the topology is the data flow paradigm between the PState and the event. So going back to the dashboard, we go into the recent spaces function. We have a look at the topology query right here. So as a closurist, I thought this was ugly. Like, this made no sense to me when I started looking at it. Only when reading about the Fragments abstraction, I kind of could sleep better at night, because it's so cool. I haven't talked about this with Rama yet, but this is basically the input. You have this partitioner hash right here. So Rama actually orchestrates different machines to store data in a. It kind of says it by itself in by naming the PState partition state. That by the org name or whatever you decide, it could be a UUID or whatever the value of org is. It hashes that function, and from the hash, it knows where to emit that data. If you remember the fragment, it emits one or more times or none. But the emission here could be to another machine. And that makes all of the org data that we have at Multiply, it gets stored at the very same place. And we can join through that data, since it's different PStates along all over the system. We can join this data together in a manner where we don't have to do another machine jump. Like, we don't have to go over the network to fetch everything. Everything is co-located in some manner. So this is what that tells us. Please go to that machine where we store all of our org data. It could be Multiply, like a string. It could be whatever, but it's hashed and it goes to that place. We check if we have a query. In this case, we don't. But you could search the recent spaces for the name of the space. A space is a project. Should have told you that earlier. Well, what happens here is we don't give it a query. We make a local select. It's part of, you that are familiar with Spectre in the Clojure sphere, it's very similar to Spectre, the Rama API. If you know Spectre, you can probably get up and running in no time. So we have the spaces with the path. We already have the org as an input. We have the account, the max amount of projects that we are supposed to fetch. We set this in a variable like this. We park it here, you could say. And then we reverse it to get the last modified project, and we return it to the original caller, which we see here. So going back, like that. the value that gets returned is a completable future, a type in Java, and our glue, which I probably won't have time to talk about, it takes in this completable future and turns it into this domain-specific or code-base-specific entity that is basically a completable future, but with some added semantics to it. Basically, in short, we need some, since agents are, in its essence, probabilistic, we could have an agent that goes rogue and starts a lot of other agents and does whatever. And this task, completable task type that Henrik has created, it's basically, it allows us to, if we cancel it, basically, if we cancel that thing, all of these subtasks that has been created from that task will also get killed, which is not the case with completable futures. Then it's just one of them, but all of the subtasks still live and has to be garbage collected somehow. Cool. Sneak peek into that. The sending of a prompt to an agent, I think we'll skip, but it's creating a task, the thing that a completable task, and it asynchronously starts a conversation with an LLM that then decides through tool calling, etc., whichever other agents it might need to activate for the prompt to get investigated, usually. With our clients, at least, it's investigative work or it's some creative aspect that they want to explore. Okay, cool. The summary, I think I'm in time, maybe. Cool. I'll summarize, and then I'll show you or talk more about the glue code that we have. So, like, there's no API. Like, I haven't thought about an API in ages, I feel like. It's pretty amazing in the speed or velocity that you gain just by creating your new UI and creating your backend function, and everything else is just handled. And with Rama, it's the thing that I'm the least seasoned with so far, but what I've seen is simply amazing. Like it's like Electric in that you don't have to care about the API, but all of a sudden you get event sourcing for free, which is an amazing thing, that alone. But then having the DSL of the dataflow paradigm to decide which machine something is going to execute in, it's crazy, the things that you can build and the things that you can scale with that DSL. Yeah, that was it. I forgot to add an ending slide, but the task as flow, it's right here, as it says right here. Since Rama returns completable futures, and by that essence, it allows for subscription of the PState, we can define it like a flow right here, like a flow of data. You could kind of imagine it like, and the recent spaces will in turn return this value, and Electric then takes hold of the value and returns it to the front end. And that was mostly the thing that I wanted to communicate here, that it's so cool that you can have the client and you can just have data streaming without having to think about it. From the browser to your server to your database and back without having to write any custom code. Yeah, that's Electric Clojure and Rama. I think I'll leave it there. Thank you.
Thank you. So now we're going to head over to some questions. You can read them on my screen and I can read them for you. So, someone asked, is Rama open source? No, but it has a free tire. Apparently someone asked and someone answered in the chat.
Yeah, they're doing a private beta as of right now, which is what we're on. But there's also a free tier. I think if it's you get 2 nodes, so you can split the workflow that I talked about. You can split it into 2 nodes, like doing the computing. And I think you have to be. I'm not sure if there's a company size or something like that, or in the license that you have to be mindful of. But you can use it today. You can try it out today.
What's being used for routing between server client? Is anything, or is it just magic glue? You don't think about it?
It's rated. Did you mean the routing?
Routing. I guess they meant the routing between the front end and the back end. I think that's what they.
So what page you're viewing?
Yeah.
That's
I mean, somehow you ship data between in the socket.
The socket you don't think about.
Okay.
It's not. That's the electric magic. The E/defen. So in Clojure you usually define a function as a defen, but the E-defen is a macro that analyzes everything. So that's not up to me to think about how the routing of data gets handled. I just define it and it magically appears. I kind of find it I'm a bit two-sided about this, because you very much relinquish the authority to have a say in how it's done, but at the same time it steps out of your way so much that the trade-off so far, what I've seen with the system that we've built, that is heavily asynchronous, and to me it's worth it. They had some earlier versions that they've now battle tested, and it's so far my experience, it's been really good.
Cool. Is it possible to attach new listeners to the depot and replay already happened events?
Yes, so you can stream. You can add how many of them you want. We did this for an index of the agents that we split it basically. We had all of the agent data and an index within the PState, and we had done a mistake in how we serialized the data to Rama. So some ordering wasn't being handled correctly. And how we solved that was that we created another topology that read all of the events in that depot and spat out all of that data in a correct manner into a new PState called agent index or something like that. So definitely.
My own question, which AI agents are you using? Or is that secret or is it open?
No, it's up to the customer.
Oh, it's up to the customer.
So we have integrations for GPT-5 and all of the latest models.
Cool. Are you yourself using any agents when coding, or models, or Perplexity, or whatnot?
I'm a big Claude user.
Oh, Claude.
So both Claude Code, but also the so B. Hauman released Clojure MCP, which is a MCP server that hooks into your running REPL and the running system that you have. So the LLM can evaluate code that it sees fit and kind of explore the system alongside of you. And that has been a very, very cool thing. You can say things like, can you please fetch me the data from this database? I don't really know what it looks like, but I'd like to see the shape of it. And it just does it. It's magic. But there's brain rot accompanied with that the way of using it. So I try to spend some time and think a lot about what the AI spits out, but also, what do I think of these things? How would I design it? And get input from the AI in that manner.
Yep. Final question. Electric helps as things get complicated, but Rama can send any shape of data and keep things simple. Why use Rama with Electric and not with React or hypermedia frameworks like HTMX or Datastar?
I mean, good question. I wasn't there when the decision was taken to go for Electric. You could definitely go for HTMX. I can see that being a very good solution for these kind of systems as well. I'm not sure. It could be. So when you prompt, you saw the prompting screen that I had in my slides. When you write a prompt and you run it, you get into this other view where you can kind of see the agents go at it and spread out and research that thing over there, and that other thing is happening over there. I'm not sure if HTMX would suffice for that interactivity and that, that visual updating, or it could. I've just played around with HTMX, so I can't tell you. What I can tell you is that Electric has done a very good job so far, but other tools would probably work as well. Pros and cons.
Thanks. I think that kind of concludes all. And thank you everyone for also watching tonight. And thanks again, Felix, for coming and presenting. Very interesting. There's one more question for the previous speaker. Please jump into the Discord server and ask it. We can answer it there. And again, thank you everyone for watching either tonight, today, or morning, depending on where you are in the world. So have a nice time. And until next time, bye.